Hello everyone, so today I'm working on the I2C protocol. Now I've almost finished the transmit and receive on only the receive type on both master and slave. So the first one is slave receiver. So the GD32 here acts like a slave and it only receives data on the bus. And on the other end of the bus, it is connected to an Arduino Uno. So here's the code, starting from the top. Oh, and another point is that I figured out how to print the floating value on the serial bus. So we need to add this line. It's an assembly code. Basically means that tells the assembler to include the floating function. Okay, now in the main function we call the demo code, and here we define the slave speed and slave address. This value 10 100 100,000. So this value is the standard I2C speed. We can also change to 400,000 for the fast one. I think the Arduino also supports the fast one. But never mind, here we initialize the GPIO-B and I2C clock, and then set the I2C, we're using I2C 0, so it's pin PB 6 and 7. Here we need to configure it as open drain because I2C uses open drains. It uses the bus end function. And we disabled I2C, configured it to slave speed, and this one determines how the high and low signal the clock period accounts for. So we just need to use like equal with. And for address config, this is for the slave mode. Yeah. So here we enable I2C. The other option is SM bus, but I don't know what's that. So here we use I2C, and the format is 7-bit address. Also, we can choose 10-bit address. It's the extended, kind of like extended version. And we feed this address to here. So here I'm putting 0FF, but actually that it's only 7-bit, so I think it's 7FF maximum. So it will mask out the highest bit. And we enable I2C. We also config the acknowledgement. So we enable the acknowledgement if we are a slave, and the position is current. But I've also tried the position next, and Arduino seems also support this kind of position. Yeah. And here we don't need this one. Here's the slave example. So the Arduino code is also acting like a master. We can change to it now. F1 else 0 to switch to slave mode, and also here we define out the master. So for the code, we first, this is basically following the guide in the user manual. So this user manual, and here it defines how we should basically handle all the requests and set all the flags and registers. So I'm using this one. Firstly, if the I2C peripheral detects a start transmission condition on the I2C bus from the Arduino master, it sets the ADD send to set. So it sets this flag. And if we detect this flag, that means that we are receiving the signal from the master, and then we clear the flag. As soon as we clear the flag, the hardware begins receiving data and put it into the register. So here we detect if the RBNE flag is set. If it is set, then the data will be ready for us to read. So then we enter this loop. Then we receive the data. This is the first data. And clear the RBNE flag. And here we only print out the data, but you can store it, for example, in an array. And then here we wait for more data, but in the while loop we also detect if the STPDT flag is set. This flag indicates whether the master generates a stop condition on the bus. So if we detect the stop condition, that means there will be no more data, and the stop condition will be 1, and then we break from this loop, and also stop becomes 1, so we break from this loop. And then we clear all the flags, and this is one transmission cycle. On the Arduino end, it's pretty simple. We just begin the transmission and writes some data on the bus and then end the transmission. So this is the signal on the bus. We are only transmitting 1 byte of data, so this part it's the X value and this part is the address. Oh, by the way, so for the circuit to be functional, we need to so for I2C we need to use the put up resistor. So here we are putting the 2 signal wires to 5 volts from the Arduino. Yeah, so this is the slave receive code for GD32.